Hi everyone and welcome to this my video on inverse proportion. Oh, I know it's very exciting, isn't it? My name is Darren from Maffs Guru. That was hilarious in 2013 when I thought I was funny, and now who can spell it? Anyway, whole new discussion. And this is part of the general Maths Units 1 and 2 course here in Australia. But because maths is universal, doesn't matter where you are in the world, I promise you this will be helpful if you are looking at inverse proportion. Now behind me you can see the learning objectives, and as I write over everything on the screen at this moment in time, you can actually download the lesson notes. Everything I write is going to be downloadable from, oh yes, you've guessed it, maffsguru.com. Head over, absolutely free to sign up. There are downloadable lesson notes, the videos for all of the topics you're ever going to need. There are VCAA exam questions and so much more coming. Right, that's the sales pitch over. What are we going to do today? Be able to recognize inverse variation, be able to find the constant of variation for inverse variation, and be able to solve practical problems involving inverse variation. You get the hint we're doing inverse variation? Of course we are. Now, this video builds very much on the video we did previously, which is on direct variation. And if you remember, for direct variation, we had this idea here that A was that funny little symbol in there, B, and that symbol there was proportional to. That means for whatever change in A, there's going to be a direct and equal change in B. Okay, but we didn't like that proportional sign, did we? No, we didn't. So we found a way of actually replacing it. And we said that if A was proportional to B, then that meant that A was equal to some K times B, some proportionality constant that is called by K. Now, knowing that, that was awesome, because what we could do then was draw a set of axes. We'd have A here, and we'd have B here, and we could draw a straight line that went perfectly through 0, 0, and we could find that value of K because we knew that the gradient of that straight line was equal to K. Now, if none of this is making sense, go back to my YouTube channel or maffsguru.com and actually see whether you can sort of watch the video. Hopefully it'll make a lot more sense. Now, that was direct proportion. We like that. Yes? How could I find the gradient? Oh, you're one step ahead of me. Remember, the gradient was equal to rise divided by run. Job done. Easy. All we needed was 2 coordinates. And in fact, for this one, it was even easier because actually I only needed 1 coordinate because the other coordinate was always going to be 0, 0. Right, we're done. Thank you very much. Let's move on. We get to inverse proportionality. Now, if I were to take a number of points and plot them against each other, and I was looking at something that might be inversely proportional, this is probably what my graph is going to look like. All right, now at this moment in time, what am I doing? I'm plotting T against B. It doesn't really matter what T and B are, they're just letters. We're more interested in this curve at the moment in time. Now, the problem with this is we don't actually know how to find my constant of proportionality. I don't know how to get this value of K. And you're going to say, hold on a moment, what is inversely proportional to? It is this here. If Y is proportional to 1 on X, then we know in the same way as we had previously that we can change this proportional sign to Y is equal to K times 1 on X. Now, I'm going to be honest with you. I actually prefer it written that way with a K here and the 1 on X there, because it then reminds me that this is pretty much in the format of Y equals MX plus C. And you're going to turn around and say, but there's no C, there's no constant. Well, there is really. It's plus 0. But do we put plus 0 in? Not at all. So I'm going to get rid of that plus 0 for the moment, but I'm going to leave that in if you want to download the notes. Now, can I ask a massive favor before I go any further? Can you subscribe to my YouTube channel? Nobody watches maths videos. I say this every single video, and like when I get 3 subscribers, I go absolutely nuts. It's like I've gone viral. I know that's ridiculous, isn't it, really? But the only way I know that people are watching this is if you subscribe. That's it. I'm really, really grateful if you can subscribe. If not, look, don't worry about it. If you can tell your mates and whatever else, that would also be awesome. But let's get back to the maths. Right. So what we now know is that if it is proportional, then actually I can work out Y is equal to K on X. But my X isn't there at the moment. Best way to show this is actually using an example, right? So at this moment in time, if I was to plot these points here, what do you think it's going to look like? Well, as it turns out, I've got a CAS calculator. So what I'm going to do is put a lesson spreadsheet in there. I'm going to put X and Y. And we're going to put 1 on 3, 1 on 2, 1 and 2, And then we're going to put the numbers 18, 12, 6, and 3. Now, being able to use your calculator for all this stuff is massive. No word of a lie, massive. What I'm going to do now, doc, insert a data and statistics. Now, if you've got a class pad, I'm 100% sure you should be able to do this. I'm going to do videos for the class pad as well a little bit later on. But here we go. There we go. We've got that nice, beautiful curve that we were expecting. Now, when I see a curve like that, I'm like, I reckon this is going to be inversely proportional. Come back to showing how we can do that in just a moment. Let's turn my calculator off for the moment. Now, the question, if it says is inversely proportional, means I can now say that y is going to be some value of k on x. Happy with that? Now, that's going to be true for every single data point. And so all I need to do is choose a data point. And at the moment, I'm going to choose the fraction one because that's the one that tricks people. But if you've got your calculator, it shouldn't make any difference. Right, so what have we got? Y is 18. So I'm going to substitute 18 equals, because there's my formula. Then I'm going to substitute k, I don't know what it is, divided by my x value of 1/3. All right, let's fire up my calculator again. We like my calculator. Let's bring it back. Go back to this screen here. Nope, that's no good. I need a calculator screen. So I'm going to insert calculator. And I'm now going to do solve, because I can do that on general maths. It's great. All right, I can solve 18 equals fraction k divided by another fraction's 1/3. I'm going to do comma k, hit enter, and k comes out as 6. There we go. Lo and behold, k is 6. Right. So what does that now mean? Well, k equals 6, which means I could have my formula. Yes, I could now write down that therefore my points are given by y is equal to k, I know what k is, 6 on x. Yay! But I need to check that. And I can check that in two different ways. I can either take another data point. So I could now choose something like 1 and 6 and work out whether that actually is going to give me the same value of k. Let's do that just as a test. Y is equal to k on x. The y value there, let's say, what was it? So let's choose 1 and 6. 6 is equal to our value of k divided by 1, or any number divided by 1 is itself. And so therefore, once again, k is 6. Now you're going to say, why are you checking it? And I'm going to say, because we could be tricking you. It may well be that this data isn't actually related in any way, shape, or form. So again, now that I know k is 6, I am very, 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 very happy. And so the question undoubtedly would say, write the formula that relates this. And I'd say y is equal to k on x. Ka-ching. Now, how do we turn a curve into a straight line, though? Well, again, this is what I'm going to show you using your calculator. This is all coming up in a later video as well. So I'm going to go back to my table, and I'm going to do here something called rec x. Now, rec stands for reciprocal. And when you take 1 divided by a number or a letter or whatever, you're taking the reciprocal. So all I'm saying is that when I'm trying to now put 1 on x on my axis, I'm effectively going to call that rec x, or the reciprocal of x. Now again, what I'm trying to say to you is our original data here is y versus x. And when I do the y versus x, I get that curve. What I'm now going to do is I'm going to hit equals, because I want my calculator to have a formula, and I'm going to say 1 divided by, I hit var, I never ever use the x because the calculator gets confused, x, and hit enter. And lo and behold, you get these other values here, 3, 2, 1, and a half. So just to shortcut what I'm doing, my original graph, which I'm going to show you here, has the lines as a curve, yes? Okay. Watch how I'm about to turn them straight line, because at the bottom, if you can see on my calculator, what I've got on my bottom axis? X. Well, I'm going to change that. And I'm going to change that to rec x. And there we go. What do you notice? A beautiful straight line. Now, I can find the gradient of that straight line pretty easily using a regression analysis. I'm not sure if you will have done regression analyses quite yet, but you will go analyze regression. I'm going to do linear, and what you see is y equals 6x plus 0. So that's basically telling me for this graph here, not this one here, for this graph here, my gradient is 6. But we already know that that actually means that my k value is also 6. He says writing without turning the calculator off. I do that so often, right? So again, we know the gradient of this line here from my calculator is given as 6, which means my k is also equal to 6. Happy with that? Right, let's look at some other examples. Use the table of values to find the constant of variation k and hence complete the table. Now, they always tell you this. So the first thing I'm going to do is I'm going to rewrite. I'm going to say, well, okay, y is equal to k on x. So remember, that's exactly the same as y is equal to k times 1 on x. So the only way we can find this value of k is if we plot the values of y against, not x, 1 on x. But we got another way of doing this because we can just substitute values. So I'm just going to choose a pair of values in my table. So my y value is 3. I've got k divided by my x value, and choosing that one there is just beautiful because it tells me then that therefore k is equal to 3. Now, having found that value, I'm going to go back and write my equation. I'm going to write my equation as, so therefore we know that y is related to k, which is 3, divided by x. So if I have an x value, I can work out a y value just by substituting it into that formula. Oh, haha, look, it now wants me to fill in some missing values. That's okay. So this one here, I've got an x value, I want a y value, so I'm going to substitute for x. So for the first one, we're going to say y is equal to 3 divided by my x value of 2. I want to put that into my calculator. Out comes 1.5. Hopefully you don't need me to do that. Okay. Oh, now they're trying to trick me. Hold on a moment. They're actually giving me this value here. Or rather, they want me to find this value here. And they've given me the y value. Doesn't matter, guys. So long as you can substitute into the formula, you'll be fine. So for this second value here, and I know my working out is all over, but I'm going to write y is equal to k on x. Do they tell me the y value? Yes, it's 0.6. Do I know my k value? Yes, it's 3 divided by x. And if I need to, and again, you're allowed to do this, I'm going to go back into my calculator screen, and I'm going to say solve 0.6 equals 3 divided by x, comma x. Now, do you notice I've got a bit of a problem there? Do you see how that's come up in bold? Do you know why it's bold? Well, my calculator's about to throw a fit because, oh, actually it didn't. That surprised me somewhat. The reason the x was bold was because I've already defined x values here, and I am really surprised that it actually did that, to be perfectly honest with you. But anyway, but it's come out with the right answer, and so in that situation, we would know that my x value there would be 5. Back to my main recording, and that's that example. Oh, look, another example. Use the table of values to find the constant of variation, and hence complete the table, right? So I've got y is proportional to 1 on x, so I now know that that's the same as y is equal to k on x. What am I going to do? I'm going to choose a couple of values. So I get here my y value is 1, my k value we're trying to find, my x value is 2. Now I could put that into my calculator if you really need to, but I know that that's a divide by 2. And how do I get rid of a divide by 2? I multiply both sides by 2. So this is the by hand method. That means that that's going to go, leaving me with k on its own, and 1 times 2 gives me 2. So I now know from some nifty maths that y is equal to 2 on x. Now, yes, probably best to go and check that that's actually true for other values, but I know it is for this particular example. Am I finished? Nope, because I found my value of k, I found my formula, and so I've got to find these missing values here and here. Right, so let's do this one here first. We've got an x value, so therefore y is equal to 2 divided by 10. That's 1 divided by 5, which is 0.2. So in that situation, y is 0.2. So I'm going to put 0.2 here. And then they're trying to trick me by doing it backwards. Yeah, but they're not, because I've got y is equal to 2 on x. This time they've given me a y value, so I'm just going to substitute. 0.1 is equal to 2 on x. And again, I could put that into my calculator, but I know that 2 divided by 0.1 is actually 20. So in this situation, x would be equal to 20. I write 20 there. I do a victory lap around the classroom. Please don't. And I'm done. Now, moving on to example 3, I think this is. And again, what have you noticed? It's all words, but that's okay. For a cylinder of fixed volume, the height is inversely proportional. Okay, so we got height. First thing I can do here is write height is, there's my proportional, but what does inversely proportional mean? 1 on the square of the radius. That means r squared. We don't like the inverse sign. I don't like. So that's going to become h is equal to k times 1 on r squared, or h is equal to k on r squared. Job done. Thank you very much. I'm finished? No. Because what they're probably going to get me to do is find the constant of proportionality. And the way they need to do that is they need to give you some information in the question. And they'll probably give you that information. You'll find out k, and then they'll ask you another question. If a cylinder of height 15 has a base radius of 4.2, right, the only reason they're telling you that is to find my value of k. So what do we say? The height was 15. Now you're going to say, what are you doing? I'm just substituting into that equation there. So 15 is equal to k divided by base radius of 4.2, 4.2 squared. I cannot do that in my head, and I have no intention of doing that at all. So what have I got here? Solve, if you will. 15 equals, let's do one of those, k on 4.2 squared, comma k. So 15 equals k on 4.2 squared. Oh, k gives me that. That's not nice. Let's see whether I can actually write that down. 264.6. Right. So k in this situation is 264.6. Yep. Now, we're going to end up with horrible things here because we're going to end up with decimals on fractions, which isn't really allowed. But it's a general maths course. We're not going to get too bent out of shape about this. Right. How high would a cylinder of equivalent volume be if its radius was 3.5? Okay. So what they're now saying is our actual formula has now become h is equal to 264.6 divided by my radius squared. That's my new formula. And I'm going to substitute in my value of r as 3.5. So therefore, h is equal to 264.6 divided by 3.5 squared. And let's see what my value of h comes out, because I can't do that in my head. Oh, covered it over. Sorry, guys. Really should have moved that over. But anyway, we're trying to do 264.6 divided by 3.5 squared. Hit enter, and let's copy that down and do it there. So my height would be 21.6 centimeters. Again, turn off the calculator, everyone, so that you can see, and 21.6. So these questions are very what I call formulaic. No maths pun intended. Why? Because you write your proportionality, you change your proportional sign for a k, you probably write it a bit nicer, you take the information from the question and you substitute it in to find your value of k, you rewrite your formula, and then you work out whatever it is they ask you to do. Another example, example 4, the time taken t to empty a tank is inversely proportional to the rate r of pumping. Okay, so first things first, let's write down my formula. What do we got here? So the time taken, so t is inversely proportional, which is 1 on the rate of pumping, r. We don't like that. So t becomes equal to k times 1 on r, or t is equal to k. Thank you. We got our formula. What are they going to ask us to do now? Find my value of k. So they've got to give me some information. If it takes 2 hours for a pump to empty a tank at a rate of 1,200 litres per minute, well, there we go. That's the 2 pieces of information I need, because to be able to find k, they've got to give me a time and they've got to give me a rate. So let's do some substitution now. We've got a time for 2 hours. Now, there is a trick here, because they've got 1,200 litres per minute and they've given me hours. So I don't want to get tricked here, because we've got to have the same units. Right, it takes 2 hours. How many minutes is there in 2 hours? 60, 20. So 120 is equal to k divided by my rate of 1,200 litres per minute. Ooh, 1200. So my value of k is going to be 1200 times. Now I'm not going to bring up my calculator for that, but 1200, 120 times 1200 gives me 144,000. Okay, so we now know that my formula becomes t is equal to 144,000 divided by r, where t is going to be given in minutes and r is going to be given in litres per minute. All right, so they've been given me that information. How long will it take to empty a tank at a rate of 2,000 litres per minute? How long will it take to empty a tank at a rate of 2,000 litres per minute? Right, so again, we're now going to say, well, T is equal to 144,000 divided by my rate, which they gave me is 2,000. And again, not wishing to conceal the screen, but if I now do 144,000 divided by 2123, what do I get? 72. 72, and it says, how long will it take to empty? I'm going to leave that in minutes if I wanted to. The question may go on and say, well, how many hours in minutes? In which case it'd be 1 hour and 12 minutes. Now, I normally go back and recap my learning objectives, so let's just make sure and see. To be able to recognize inverse variation, yes, anything that does that when I plot the original points together. To be able to find the constant of variation, yes, you basically choose two of those points, or one of those points, and put it into your equation. Be able to solve practical problems, yes, we did some with graphs and some with tables and some with just worded questions. I think we're done. So I'm going to say thank you very much for watching. If you can subscribe to my YouTube channel, that would be massive. If you want to head over to maffsguru.com and sign up, again, huge. Thank you very much. There are more videos coming in this series, and hopefully I will see you in one of those. Otherwise, please take care and stay safe.